It's a great city, by the way. I really like this. It's my first time here. And I'm here to talk about functional programming in C#. And yeah, what's that about? So a little bit about me. As I always say, I'm just another guy with GitHub and Twitter as everybody else. I'm from Czech Republic, from a company called Muse. We are a global company. We do software for hotels, and I'm something like a lead architect there. So yeah, I guess that's enough about me. I'm not that interesting. So why would I talk about C# when you have F#, right, in the .NET environment? But let me ask you, so that I know who I'm speaking to, how many of you know functional programming? If you can raise up your hand, okay? And then please keep your hand up if you are a functional programmer that you really feel you. you do. Okay, great. Who among you tried F#? Okay, who tried it more than one day? 2 days? Okay, those are the survivors. Okay, so as you can see, there is not many F# programmers in community. Or have you tried Haskell? Who tried Haskell? There's more than F#. That's pretty nice. Okay, but there is generally not many guys doing F# or Haskell like in a job or something. So and the market is tough. Like hiring developers even for C#, it's pretty hard. So hiring developers for F# is even harder. So that would not be a good way to go. And another thing is, like, we are usually not on a real field, right? We have some big code base written already in C# possibly. So like starting out with F# is pretty hard. And so at Muse, we took like another road. We will go with C#, it's a good language, and we will kind of incorporate the functional concepts there and teach it to the people who have never heard it, like gradually. Okay. So what really is functional programming about? It's really hard to define what really is a functional program, which is object-oriented programming. And it basically goes down to something which is called referential transparency. So yeah, there is one disclaimer. Functional programming is known for a lot of big, crazy, scary words. One of them is referential transparency. So what it really means is that if you call a function with some arguments and you know the argument, you can replace it with the return value. It means that the function does nothing else than return something to its output. And you probably, no, this is not the slide. Okay, it is. You probably know the function more as like a pure function. It's not the same as referential transparent, but you can imagine like that. So the pure functions don't really mess up with the state. And why would you want that? Why it's like important to have this property in your code is that basically there are no surprises. You like how many times it happened to you that you were like, oh, I didn't figure out this function sends email, or I didn't figure out this function talks to a database or something like that, or changes the state in a weird way. So there are basically no surprises. Also, the testability is super easy. You just put the values you want there, it gives you an output, and you assert the output is what you want it to be. But really, the core feature is that there is no time or state factor. How many of you read a paper called Out of the Tar Pit? Or how many of you know it? Great. So really, they talk about software complexity and what's the main reason why software is complex, and it's the state. Like the state factor, it's the hard part, and that's why functional programming basically tries to tackle it by pushing the state to the bounds and having the core pure. And it really is easy to reason about this because you don't have to have like the global state in mind. You just look at the function. You can reason about the single function individually. Then it's also easy to parallelize, right? Because the parallelization is hard when you have the shared state. And it's easy to cache because the function is deterministic, so it always returns the same thing, so it's not hard to cache it. Yeah, but as I told you, it's hard to define what really is FP and OOP and stuff like that. So I'm not going to show you like functional programming because I don't really know, or it's hard to define, and the two of those can overlap. So you can still, as we, stick to your like object-oriented code base in the big, and you can just try and use these concepts like from the ground and incorporate it into your brick code base to improve it. So most of the concepts are doable in like OOP languages or with an OOP code base, but they usually go with the functional programming. So let's see if we can do that. Is C# good enough to give us the tools to do the functional programming? Well, we have functions, like that's already a pretty good start for functional programming. We have several features which makes like programming in C# possible in a functional way, but still there is some stuff that's missing. So we have to help us out with the library, right? So there are two libraries. I'll talk about the first one because we wrote it. But there is this other one, which is called language extension. Who knows language extensions? Okay. It's a really big library written by a guy from Haskell community, and it's super, super big. And basically, starting up with this library is as hard as starting out with Haskell. The learning curve is really steep, and that's what Func# is not about. Func# is really a lightweight library. We made some like other decisions, so it's a good choice between it. But I think the Func# is bad for start, but with starting out with functional programming. The language extension is something that you can evolve to, like in the final stage. But Func# should hold up to most of your functional state stuff you want to do in C#. So yeah, let's like dig into these concepts, techniques, and patterns that I want to talk about. And I'll kick off with expressions. So you see this code? It's shitty, right? So what's about this code is that it uses statements. So there is some state, which is basically not global, but can be viewed as global. Then you have like if something, change the result to 1, something else, well, you would not write it. You basically all would do this, right? And this is what expression is. Like the expressions are like composable, they are pure, because statements don't return anything. So that means they usually mutate stuff. That's why we don't use them. And they are hard to compose, because stuff that does not return stuff, you really cannot compose it with other stuff. And functional programming is really about composing stuff. And yeah, so we solved the first like the if and else with the ternary operator. But what about this? Like try and catch, there is no like expression way how to write a try and catch. So you have probably all seen some code like this, and it's not nice. We will get rid of that during the talk. Yeah, immutability. So I guess you know that one. So immutability is a great property of that nothing changes. So basically, when you have a function like a printer of a person, you have no guarantee that the printer won't change the person, right? It would be a silly implementation, but I guess we have seen some of those. So basically, everything can be mutated, and it adds to this like state factor and everything else. So by immutability, you make the person like not mutable, and then we can really trust that nothing will change. And there is also this that people are like, yeah, but it's a waste of memory. It does, or sometimes people say that it's not important, but actually, sometimes the immutability is even more performant than mutable stuff. Let's say Git. Like Git is also not written in a way that it's basically immutable. You only add the changes, and from the changes you build up the whole structure. If you would do it in an object-oriented way, you would have to basically do a deep copy of the objects, like of the code base, all the time. And there are even like graphical algorithms that really rely on immutability. So it's a really good thing to do even in non-OP languages. And how we do that in C#, we just write a class with only a getter. And then the objects, those objects usually have this pattern called like copy on write, where you have this with email, and you basically put a new email address there, and it returns a new person. And you always know when you reference to something that it's the same stuff, it has never changed, so it's good for like parallelization, And also, like the functional data structures which are immutable are smart. So when you have a list and you add a single element at the end, it's not like that the list is copied all the way. It's only they do stuff which is called structural sharing, that they share the structure, and it's basically a single element with the pointer. I'm a new version. The rest is the same. Yeah. Now we are getting to more like good stuff. So algebraic data types, also a scary word, but that's like, I guess if you can take something from this talk, take this. Like this is the most crucial functional feature, and those are algebraic data types. So what are they? Well, even OOP programmers, they use inheritance. They started to say stuff like composition over inheritance, right? So algebraic data types are just composable types. There are two of them, product and a coproduct. Product basically is an array tuple, which you know, where you have the AND relationship, but the coproduct is stuff that's usually new for people, and that's the OR type. So yeah, the product is really simple. You just say that you have something and something and something. That's basically a tuple. So then you have a point, you have like an x and y, so that's a product of two integers. And yeah, you can basically use system.tuple for that. And even like a product of a single thing is useful for aliasing of the types. When you want to say like that you have a string, but you want to say like a type mail address, you say that the mail address is a product of one, because it will add you like a structural equality and proper implementation of get hash code and stuff like that. But coproduct is the interesting part. So let's say you have this paragraph reader, and it can read something. What is probably the return type of the read, right? You don't really know. And even if you look at the .NET implementation of the car reader does not return a single character. It returns an integer in order to say to you that if it's like -1, it's the end. It's really hard to distinguish like for this kind of stuff, and you don't really know what this returns. So in a coproduct, you say it returns either this or that. So whereas in the product example, we have like the AND relationships, here we have the either relationships. So we can say that the read result is either a line or a paragraph AND, or a document end. It didn't fit there. And then you have like nicely documented what it returns, and it won't allow you to touch like the other branches of the coproduct. You basically have to do something like a switch on it and see like if the single cases, I'll show it later. So that's nice. You can basically think of it as a single level, non-extensible inheritance, right? But that's the good part about it. It forces you to compose the stuff. You cannot really inherit it. You have to put it in. And it's easier to add the behavior, because then, I have the example here, I think. Yeah. Okay, I'll talk about it later. So yeah, and it's great for domain modeling. Like once you know this and you really try it, you will never stop. And yeah, that's great. I'll show you more examples later. So with the coproducts, as I said, you have to do some kind of a switch to how to work with the coproduct to really distinguish the cases, and that we call pattern matching. It's something like, you can imagine it as a regex on objects or something like that. You basically say what's the pattern there, and if it matches the pattern, it will like execute the branch. So yeah, sorry, this is F#, but never mind. So you can see like that you have like the tuple, and you can say if the first one is 5 and the other one is nothing, do that. And we match like this. And the great thing about pattern matching is that it's usually exhaustive, which means that if you add another case, the code won't compile. It will tell you that you have to extend this functionality or a function to match it. So let's see the final example with the reader. Here is how it looks in C#, that you have the result, which is like the coproduct we have shown, and then you have the match there, and if it's line, then you process the line. If it's paragraph end, you process you end the paragraph, and it's end, you end it. And if new type is added, this code won't compile. It will tell you that there is not a match function which only takes 3 arguments. You have to provide 4 functions there, which is nice. And oh, I won't spoil this for you. I'll leave the F# there. Oh, shit, that's another F#. Yeah, I'll leave this to the other session. So something that really goes with the products and co-products is type safety. And also, again, this is not something special to functional programming. It's just we cannot lie to our callers in functional program because we cannot really mutate stuff. We have to return everything, so the types are more robust. So one thing with the type safety is domain modeling. So let's say you want to model this class job, which represents some background job, let's say. It has a state. It's either pending, in progress, and finished. Then it has some percentage of the progress and a result. So what's in the result if the state is pending? Or what's in the percentage if the state is pending or finished? Like basically the percentage should be always 100 when the job is finished, but it's not enforced on the type level. And the result also, like what's in the result? Yeah, probably null, but that leads to null reference and a $1 million mistake. So we don't want to do that. So how to fix it with the coproduct? We can basically say that the job is either in pending, or it's a progress job, or it's a finished job. And only like the cases have the meaningful data they should have. So the in progress job has the percentage because there it makes sense. In the finished job, it has the result because only there it makes sense. And in pending job has nothing, for example. And then you say that the job is coproduct of, like it's either a pending job or in progress job or finished jobs. And it's really nice because this is like a super nice documentation, and you can really restrict your types to only few possible valid data. So it's pretty hard to even have invalid data because the types themselves forbid a lot of that. And then you can use the coproduct and coproduct to combine them and build more types. So if you want to add a name, which should be in all of the cases, you just say that you have the job state, which is the 3 cases, and the job itself has state and a name. And you can see how like the product and the coproduct composes, and you can basically build everything. And that's not a coincidence. You can build everything. That's why they are called algebraic data types. You are good to go with just a simple type I will show later, and you can build any type in the type system. Another thing about type safety is code deduplication. So let's say you have these 2 functions. One creates a date from 3 integers. The other one returns a calendar for a given month. So the proper implementation of both of these functions should be like this, that you check if the input is valid, and you throw an exception if it's not. But this makes the code basically duplicate. If we introduce like the month just as a special type, we say it's a product of integer. We make the constructor private so nobody can really create it. And then we have a constructor. This is called smart constructor usually, which checks the input only in a single place and returns the month to the world. And then everybody can use the world and rely on the value being correct. Yeah, so this would not be the proper implementation in a functional way because we have exceptions and stuff like that. But it keeps the information in one place. Another thing, this is just an example on how to model it because actually the best way to model a month would be as a coproduct of 12 stuff, right? It's either January, February, March, April, May, and so on. But for stuff that has let's say infinite amount of values like email, you cannot really say that email is either a@gmail.com, b@gmail.com, and everything. That would be like the ideal way, but that's not possible. So you make this compromise that you say, okay, I will guard the value for you and guarantee that when you have the month or the email, you have a correct month or email there. And then we can change these methods to really take only the strongly typed types and not care about them being correct, but just being them correct together. And then the date holds the invariant that they together form a proper date. Another thing is like that the function has an honest signature. That's the no surprises part. Because for this, it gets a person from a database by ID. What does it return when there is no person in the database for that given ID? No, sometimes. Sometimes it throws an exception, right? You don't know. You have to look into the implementation or in the comment to see that. And we know like how it goes with the comments, right, in the end. So that's not nice. What we can do, I'll talk about more that later, but there is this type, we say that the function returns an option of person. It says that it may be the person is there and maybe not. And we are forced, we can like nicely see on the type signature what really is the function about. That's, we call that making the function total, that it has a result for every input basically. Yeah, and one like really good thing that we usually do in functional programming is that we prefer to put more decisions in the caller over the callee. Like callee does not know the use case. He does not know what's happening. He should just return the information to the caller and he will decide what to do with that. We'll see that more later even. So yeah, here are the special types I want to talk about. I'm not sure why they were not there. But yeah, so there is this special type I want to mention. It's called the unit, and it has a single value. It's like it has only a single thing. It's not useful. But why is it useful to use it? So you have this like function versus action. Why do we have it? Like it's the same stuff. It just does not return anything. So basically, you can say that a function that returns a unit is an action. And you can really get this deduplication of generic stuff versus not generic stuff gone because you can only put the unit there and you know it does nothing useful. And another special type is called nothing. And it's a like type that cannot be created. And why is it useful? Well, some functions do return nothing, right? For example, this function, it will never return anything. So you can like know on the type level that this function won't return you something. So you can, for example, have a function like fail.contract, right? That you basically say here it went wrong and it should return nothing. But the semantic is not supported by C#, so it will like still force you in lambdas put the implementation, even the code will not ever be triggered. Yeah, so let's use, this is like the basics, and now we can use the stuff we have learned to actually build stuff or do more. So one thing I would like to introduce you to is option, and I like to start with this following code. It's it's something. It's pretty random code. It adds a 5 to the input, and then it tries to divide it by 42, and yeah. And the code is pretty noisy. Like, who likes this code? Nobody. So what we can do about it? Let's see. We can refactor it like this. Who likes this? It's better, right? But it still misses something. What's bad about this is that like we basically made all the preconditions in the one place, and then we have like the functionality in a single place. But what if there is some like precondition edit? You can easily forget to check it, and yeah, that's not nice. And as a programmers, we do forget stuff. So what we can do is to introduce this option, and it's a coproduct of, it's like a generic thing. It's a coproduct of T something or unit. So it's basically a nullable type. It says either there is some value or there is basically not nothing, because nothing is really nothing. There is unit, which means like the type is not there, it's null basically. And why is it useful? Because we saw that on the coproduct, we have the only way how to work with the coproduct basically is via the match, where for the coproduct of 2, we will have 2 cases, and it will never ever let us write a code which does not state what to do if there is null. So no null reference exceptions. Yeah. Yeah, so now we can use it, right? We can, sometimes the option is also used for making the function total. So for example, division. Division is not total. Division is not an operation which takes two integers and returns an integer. It's operation which takes two integers and maybe returns an integer, right? If the other one is not null. So we can write this function. So we say like divide. We say that if the b is 0, the match here is basically like a switch. We say if it's 0, then like return an empty option, like nothing was there. In the other cases, just divide it. You know, it's okay here. And from now on, like nowhere in the application you have to think about like when the division can fail. You just call it and you behave like based on the option. And then we can compose it. This is basically the same function as on the previous slides. Who likes this? Like the letter function?
It's less readable from the very beginning.
Yeah, exactly. It's less readable when you don't know it, but you know it. It's like this. Who knows IEnumerable and select many? Everyone. And actually, it's the same thing. Option is just an IEnumerable of 0 or 1 element exactly. And in the map, as you can see here, it's the select. And the flat map is the select many, because we have the input like it's an option. So let's say it's an IEnumerable of integers, or a single or one, like none integer. We select all the elements there, we add a 5 there, right? Now it makes sense. Then we have the division, which returns an option also, so it's the same thing as it returns like IEnumerable of something. So we have to select many on that. And then get or else is basically a function which says if there is no element, return this. So, and it's really nicely readable, and you cannot forget about the error handling in this code. It really forces you to do it like this, and when you get used to, it's really readable. Actually, some smart guys in Microsoft thought that like it would be nice to write SQLs in C#, but they came up with something that's known as a do notation in functional programming. C# programmers call it LINQ, I don't know why, but you can use LINQ on all the types that have select and select many. And there is a lot of types that have select many semantics. We will see some more later. And you can use it. So when you have basically two options and you want to add them, the implementation can look like this. So imagine that instead of the from keyword, imagine var. Instead of the in, imagine equal sign. And instead from the select, imagine return. Now it's like just a simple code. So we can use that instead of the first example where we need to flat map. It gets messy. The LINQ can help us to solve that. And yeah, this takes some time to get used to, but the benefits are really huge. So error handling. So the options show us a bit about the error handling. But what if we want to know why it failed? Like the option only says it failed. That's not really useful. We want to add some information. So yeah, this is some code, which is, I guess, usual for some code bases. You have the sign up function, which takes credentials, returns an account, which is of course not true, right? Create signatures, sign up email, which takes an account and returns an email. That might be true, but we don't know. And then we have this try catch, and for all the cases that like happened, we catch the exception and do something. What if, like, if I would just ask you, like in your code base even, what can go wrong with the sign up? You don't know. You would have to look into the code, and not just into single function. You have to look in the whole tree of functions, and maybe even like the ones called from like the .NET base class library. That's not nice. So basically when someone extends somewhere in the code tree you called some exceptions, you will forget to add it here. So we don't want that, and also we don't want statements like the try catch, right? So let's fix it. So let me introduce itry or try, which is just a coproduct of two. It's just an alias basically. with some like nice functions, and let's fix it. So we can then define an enum, like a sign-up error. We state everything that can go wrong. So the account already exists, the email is invalid, the password is too short, or there is even no connection, like to some third-party service or something like that, or to the database, if you want to handle that. And yeah, so notice that basically enum, this enum is a co-product of 4, where all the types are units. They are just nicely named. And then we say that basically signups either returns an account or some signup error. On the type level, we have it given. And now when I ask you what can go wrong, it's super simple, it's right there. And then the create signup email, for example, has no problem. And then we can do also, like the map is the select one is the flat map. So we can do sign up, and we have like the try of account and sign up error, and then we map on the account only. If it's like, okay, it will go through. If not, the error will still stay there. And what's also nice that in C#, then like the consumer of this will basically match, yeah?
But how do you know, like, you put it in a signature. I try with account or sign up error, so you got a core product, that's nice. But how you guarantee actually the sign up is calling some other libraries, and then some of them throw an exception that you don't handle. So it still can throw an exception. There's no guarantee as well, right?
Well, you can do several stuff to prevent that. Like, of course, with the libraries you cannot. No, you have to wrap them up or like dig in the source code. But if you want, you can just forbid. You can write an analyzer to forbid a throw keyword, or like you.
But if you're using some third-party stuff.
Yeah.
And
Yeah, you have to write a wrapper. Like if.
but then, yeah, you can write the wrapper also in the previous case. So, like, you sign up because you get try catch with the with the exception type, so catching everything. So you have it as well. You've got the same wrapper, so basically the same.
Well, it's not really because like now we have the sign up error, and what the consumer will do, so that's where we're heading, is that it will match on the I try. It will say like if it's success, do something. I have a nice code example maybe later, so maybe let's do the questions at the end, and I will go back to it. Maybe it will make more sense with the context of the whole presentation because I will revisit this idea. Yeah, so yeah, the errors are strongly typed, and then when you match on the error, it will like on the match on the enum, it won't force you to handle everything. So that's why ideally you would either write a function and an analyzer, like talking about C# in F# is easy, but talking about C#, you can either write a match function on an enum and an analyzer which will check that it's exhaustive, that you handle all the errors, or you can use the coproducts instead of enums for errors, and there you have a guarantee when you add the error case that you have to handle it. Yeah. Yeah. So we can also like combine that when the create sign up, you will also return some error. Now this is more real world example, because then when the functions return a different error, you basically have to create another error and map it to the common error. So you like call sign up, then you map error to create the common error, and then you do flat map with the create sign up email where you also map it to the common error. This is like this is something that people don't do with exceptions, but should do anyway with the exceptions, because like you should only talk about errors like within the layer which makes sense. So, for example, sign up should never throw an exception which says file not found, because that's like it doesn't make sense. It exposes the internal implementation. You should catch the file not found in the implementation of sign up and throw a new exception which makes sense. Like for example, your user is already there or something like that. Yeah, the weekly type variant is not true anymore in the new version of FuncSharp, so I'll skip that. But you can convert your code base slowly with using itry of anything and exception, and slowly like restrict the error type to have less values, and get there. Yeah, then validation. So basically, functional programmers say something like, don't validate, just parse. I'll showcase that. So the validation is basically when you get an input, you want to return if it's good or not, but usually you want to return like everything that was bad. So if a user fills up a form, you don't want to say like the first name is bad, then he will resign up, the last name is bad. You want to give him all the errors at once, and I have seen some implementations of that, so this is the one. Who likes this one? Who did it this way already? A few hands. That's not nice. And the try can basically solve that for us. So when you have a try of we are creating a person here, right? Yeah. So when you have a try of a person and you have like an error array, and you have these like simple functions. This is like a create email, or it should be more named parsed email, which takes a string and returns the itry of email or the errors. Then you have the create name, which takes a name. This is like a simple implementation. It returns this. And then you have this nice function called try aggregate. It's usually called apply in functional programming generally, where you like give it a set of functions, and then the last function which says like if everything went okay, I'll execute this function. If not, I will aggregate the errors and give you all the errors at once. And like compared to the previous example, this is super nice.
You could use link here as well.
Yeah,
Or not?
you could basically. Kind of. Yeah, so we are getting more to the end. So this is some more like bigger example of how the shift of the object-oriented code can be made in C#. So let's say this is some endpoint in our code base. We retrieve the person by ID. Then if it's null, we return HTTP not found. Then we try to do something. If something happened, we return bad request. Otherwise, we return OK. This has all the bad properties we have talked about throughout the talk. And I'll put like everything together to how it can look like. As you can see, the code really shifted to just few lines. That's usually what happens with the functional programming. And then you can see how the types of the operation changed. So get by ID does not return like the person, but option of the person. And the do something returns itry of a unit because it's like a void function, so it returns nothing really interesting for the caller. And then you have the person, you get it by ID, then you map it to do something, and then you are forced to match on like everything that happened and decide what to do with that situation. So if the person was there and the operation was success, it's like HTTP OK. If there is one error, you can do bad request. If he wasn't there, it's HTTP not found. There are various ways how to write it. So this is one of them just to showcase you how to use all the stuff together. Yeah, and then there is this question. Pure functions are nice, but I have a database, right? My customer does not want a program where he puts like something, it computes something and returns 42 and that's it. I want a meaningful program that stores stuff to the database. I want forms, and basically most of the applications are just CRUD. So what to do with that? And yeah, that's the hard part. In functional programming, they say like, yeah, the state is the hard part, so do it as least as you can. Most of your application should be pure, and only at the edges you have to do some like I/O or stuff like that. So basically, from now on, we were designing the application or talking about how to write it from bottom to up. We were talking about the function level and methods, but now what about the whole application? How to write it? What to do with I/O? And like it's pretty hard, but the simple way is something that Mark Seaman calls unpure sandwich, which does not always work, but it basically means load the data, process it by a pure function, and then save the data. So most of your like pipeline is unpure, just the edges aren't pure, which is nice, but it's not always applicable, right? Imagine that there is if like in the computation that you want to load just this or that. That's not always applicable, but if you can do it, this is like a good start, maybe to do it on some places. But then it gets a bit hard. Then there is like this thingy, the type called IO, where you basically, the function states on the signature that it's an IO function. It will do some IO operation. So here, like the getRecipe function takes an environment and the ID and returns IO of the recipe. Oh, it should return IO of option of recipe. But it takes it basically, the only thing it does, it states explicitly that it's an IO function, that it will do something nasty. And then you basically know that most of your code is pure if the IO type is not there, because you cannot really, like, you cannot pass the IO to your pure functions. Yeah, so that's something. Then you can use the link queue with it like this, because there is also with the thing with select and select many. Yeah, then we can also improve it, because here, as we can see, we have like the environment passed all over the place. That's not nice. We can use a reader for that. Well, like this part, it's only because I don't want to leave it up you with the question, and what about IO? But really, like, you should not worry about the IO until you know like the basic stuff. This is really not something, this is not the main topic of the presentation. I just wanted to give a sneak peek of how it's solved in the big picture. Then you can use the reader, for example, to clean up the environment. Then you can see the environment is not there. There is a library called C# monad, which will allow you to use that. This is not in func#. Yeah, then you can take it to the like super level. There is this super famous library called Zio. Who knows Zio? Yeah, I knew that you, okay. It's a Scala library, and it basically takes the IO and the reader and task and everything together and creates this big type, which you can use, which is super nice. Yeah, and there are also some alternative ways. They are called like free monad. I scrubbed it should not look like this. Okay. Basically, that you build up your, yeah, what's nice about IO is that you have to execute it in order to do something. So you cannot really do the IO operation in the function. You have to return it to the caller, and he will execute it. That's why he's forced to know about that. And so then your program is basically a function that gets executed on the top. The alternative way is to basically build a generic data structure. You say that, for example, your repository is a coproduct of get user by ID and stuff like that. And then you compose it, and you make like the base data structure, which is just a description what should happen, and then someone else will basically interpret it and execute it. Yeah, Mark Seaman has some nice like talks about that. Yeah, here are some links, and that's it. Thank you for your attention. Now I guess we have time for questions, I hope. Or if there are, yeah, so questions?
Like, as a F# fan, I'm saying why, like, I see all this effort because like we don't want to teach F# because it's seen like a sort of like an extravagant language. But wouldn't it be like I feel like for many simple cases actually F# is kind of simple. So wouldn't it be actually easier to teach like C# program a little bit of F# and just use reference and F# assembly and
okay,
do whatever?
So I'll repeat the answer for the live stream.
Yeah.
The answer was that it's not easier to use F#. I always get this question, like always. So thank you for like filling up the sheet today.
Yeah.
Yeah, as I said, it would be nice, but for big code bases, like our code base has 500,000 of lines. Rewriting to F#, good luck. It's not possible. And even the creator of language extensions, everybody asked him like, what the fuck are you doing, man? Like, this is so huge, just go to Haskell and leave us. And he was like, yeah, but I was forced to do C#. I have a big code base. it makes money, I need to maintain it, but also I want to put the functional principles there. So yeah, when you are on a green field, you have a small team and some skilled functional programmers, go with F#. But it's like, as we are taught in programming, that you should have your own toolbox and use the right tool for the right thing. When the F# is not possible or not a good like fit for the project, this is a nice way how to incorporate some of the stuff in C# and stay sane even in C#.
Because yeah, I get that you don't want to rewrite everything, but like you could just rewrite super small steps and just have like assemblies, for example, for I don't know,
Like with F# it's a bit easier that it has the interop with .NET and stuff like that.
Yeah.
But still, like even from the hiring perspective, if you write that you work in F#, people won't apply because they don't know F#.
Yeah.
But if you write that you do C#, they will like, yeah, I know C#, that's okay. And then they slowly like get used to it because like learning another language like F# and learning these principles is a lot to have on a plate. But learning these principles in a language that you are comfortable with can be much better because you are like good with the language and you can nicely understand the principles from the environment you feel comfortable with. And so you can even use it as a step. So let's say you have a company which has multiple projects. You can have some projects in the C# for like juniors, mates, and then the seniors have projects in F#. Yeah, so I hope it answers your question. And you get yeah, so it's nice to have it in F# or like that, but it's really hard to hire guys to do F#. Like I'm not sure about the Amsterdam, the state of here, but in Czech Republic, there is this F# meetup I go to, and that's basically like all developers in Czech Republic that do F#. I don't know, 20, 30, the few tens, like it's, and most of them are C# developers who are trying to learn F#. Like there is really few skilled developers in F#.
Yeah, because I feel like from the F# community, sort of that is sort of that we are fighting against ourselves when we, like, in a way, but
like yeah, but as I always say, like the most known programming language is JavaScript. So like world is out of his domain. So okay.
Isn't JavaScript considered a functional language?
Unfortunately, it is.
But unfortunately, you
but
wouldn't.
the principles of functional programming are generic. You can use them in any language, basically. So, yeah, I just don't like JavaScript. It's
But you wouldn't call JavaScript then a functional programming language.
Like, if I would be forced to write JavaScript in some jail or something, I guess I would be trying to use the functional principles also there. They have pretty nice libraries for, like, I think it's Lodash, Lambda. In TypeScript, they have TS, FS. So, yeah.
But now to my original question, you said that there are few people applying for F# jobs. Why do you think that's so?
Are we getting philosophical? Well, like, my personal opinion is that it's not taught in schools. Like, in schools, everybody is taught to do object-oriented programming, and you learn that, you make a lot of money out of that, and then people are not, like, good with changes.
I would say something there because you say object-oriented programming, but the opposite or the alternative to functional programming is not object-oriented programming because you can do object-oriented programming, functional programming. I think you want to say imperative programming.
Yeah, okay. That's a bit better word, like that imperative programming. But you can also write a functional code which is imperative, so it gets messy. But yeah, like people don't want to change usually, so they learn the object-oriented way, they make money with it, and like, why would I change?
I don't think it's the object-oriented argument because you can do object-oriented with the functional too.
Well, like in the bigger picture, yes, but in the scope of the whole application, that's not really possible. Like if you are designing the whole application, the object-oriented design, everybody is used to container, like dependency injection containers and stuff like that. That's not really a way for the functional app. So if you really want to have it functional, like the pure, like in Haskell, that's not possible. That's not the same.
So then you would say that skills are missing in the market because they're not taught by the schools.
And also functional programming, it's not coming from the bottom. right when we started to do like programming overall, we did assembly, then we did a bit higher, and we are going from the bottom. Function programming is going from the high, from mathematics. It's like it goes from a theory which is called category theory. It's a really abstract branch of mathematics, and like the concepts are from there, so it's getting like down. So that's also why people fear that, because it's like math and it's hard and stuff like that. In order, you don't have to know category theory in order to be a functional programmer. It makes you a hell of a programmer if you know it, but you don't have to, and people think they do. So everybody is like, I don't have a PhD from informatics, I cannot do functional programming.
One more question.
Hello. This is, all right. Well,
It's especially for NV. We is watching from Nigeria.
oh, hey, hey, man.
We can also hear you.
Thank you. So my question is a lot more technical than these philosophical questions.
Yeah.
Did I understand correctly that when you can use try with two different, with either one or two type parameters, and if the second type parameter is absent, then that means that it's either a success or an exception. Is that correct?
The try without the second parameter is something I forgot to remove from the slides. Because like in the previous versions of func#, the try of just A was try of A and exception.
Yes.
Yeah, so yeah, I forgot to change the
So
slides
how
to that.
do we do it in the new version?
In the new version, you would have to explicitly say it's an exception that you are returning, which is not nice because it's
Oh, okay.
also it's try of A and like something and exception.
So basically, it's an either. What's in other functional languages
Yeah,
is called
try
either.
is either. Yeah.
Okay. Well, I like the one parameter option. It looked cool, like that by default is
The
exception.
option still has a single parameter, but the try has two now to force people to put the exception there. We had like a pretty big experience with that, and we like decided to remove it for the good.
Okay.
Because
Well-
you should not return exceptions, but some strongly typed error.
Oh.
Usually.
I see. I think it's pretty clever.
Thank you for the question.
Cool. So is that correct understanding that you are using this functional paradigm at your work?
Yeah.
Right. And did you rewrite it from imperative style to functional programming, or did you just start implementing new modules in this functional programming?
So when our CTO 7 years ago started to make the code base, he first read a book about category theory. And so he wanted to write the whole code base in Scala, but that was not possible. Scala wasn't even production ready back then. And he was like, yeah, I will not like hire many developers. So we wrote it in C#, and he wrote this like library to help him out. So in some sense, in the code base it was already there, but as we grew, we hired like developers which were not used to this way, and like as it was a startup few years ago, there was some code that was like made quickly, so it was more like object-oriented or imperative. So we are transforming like slowly the parts that are not there to the functional way.
Yeah.
So. Yeah.
So what are the changes that you see when you go from the imperative stuff to the
Less
functional?
bugs.
Do you see any, come again?
Less bugs.
Less bugs.
Because
But-
like if, I don't want to steal more from your presentation, but when I write in F#, I'm pretty sure it works on the first time I compile it, because the types help you so much that it helps you really not to forget anything and restrict the types to a lot of. So when you have the try, you cannot really forget that this can also fail or this can also fail. You're really forced to program around all the use cases, and usually that, in my experience, results in much like less bugs.
So how would you compare in terms of size of the code base, in terms of development of a feature from imperative to functional, and then in terms of performance?
Okay,
Those are three things
so
that...
in terms of size of the code base, it's much smaller. I have seen code bases or heard about that there were in Java. It was about 500,000 of lines, and they rewrote it to Scala, and it was like 100,000 lines. It was like 5 times smaller. So the code is usually much less lines. So it removes a lot of boilerplate and stuff like that. In terms of performance, there is nothing like that. Functional programming does not have any like impact on performance. Like generally, I cannot say something about performance in such an abstract concept. With the immutability, as I said, it can either improve or decrease the performance. Sometimes people think the performance is worse, but it's not actually true. And you can, like the performant heavy code, you can have that like written in some low-level techniques to prevent it, but you should not like have it all over the place until you are writing a game or something. Then you are probably not gonna do that. But it has no like, there is not really some statement I could say that do not do functional programming because of performance. That's not true, definitely. Sometimes even it can help performance. So, yeah.
And then in development time?
In development time, like that's also pretty abstract. I would say it's much less because it works. So in a way that you are forced to do more of the work when like writing the code, but then there are less bugs. So it also reduces the development time because then you don't have to fix all the bugs years later. And yeah, that's in my experience. Yeah, but if you have any other questions, you can talk to me after the talk if we have no time here now.
I would like to thank you for presenting.
Thank you. Thank you. Thank you. Thank you.
I have good news and very good news. My stress level is back again to normal, and the food has arrived. So we need to figure out a way to do this. So let's take 50 minutes or so to get something to eat, and come back here, and then we continue on the presentations. So we don't end too late for people that want to go home early, or at least it's not early anymore. Close to it. Today, it's great. I could see it. Yeah. Oh man, the guy that delivers the food, his cell phone broke down last week, so he couldn't access his calendar. So I called him, like I think 25 minutes after he was supposed to deliver the food. Like, hey, what's going on? The first tried to call his phone, and then I called the store. What's going on? Oh crap, I'm very sorry. I'll be there in 30 minutes. But anyway, you have to work that. Get something to eat. Yeah. I hope it's enough. Yeah. Otherwise, I have a second problem.
But also, thanks for the opportunity for Codemotion.
Yeah, sure.
I think they've done a lot of cool community work.
Yeah, certainly. Yeah, because Alba left.
Yeah.
She's now working for something code. Open code or something, or government? Yeah.
Okay.
I wasn't sure what it exactly was, because I had a chat with Kelly something. I think she's Dutch. I assume from her surname.
Kelly something. Yes, she sent me the code.
Because I sent her a mail this afternoon, like, okay, do you have a code for me? Then I can also try that one out. And she sent one back.
Oh, so you also have one?
Yeah, I have the same one as you have. I
Okay.
think. The bit.ly.
Yeah.
They have two.
Ik moet helaas nu gaan.
Dat is geen probleem.
Om de volgende staat terug te kunnen kijken?
Ja, we nemen hem op.
Ja.
Laat ik even, als je één seconde.
Ja, tuurlijk.
repetition makes, like, you learn things better, right? But at the same time, you'll have to learn a new language, like a small thing. So I'm going to speak about function programming language F#. And F# is multi-paradigm language, but I'm going to speak about functional side of F#. Like, you can do object-oriented things with F#, but that's not our focus for today. First, like, what is functional programming? And honestly, I don't know. That's sort of like vague thing about functional programming. It's a style of programming, let's say, where you use a lot of functions as building blocks. That's as good as I can get. So if you have functions, you already can kind of do functional programming again. What is F# if you don't know? Well, it's a .NET language. These days you can also compile it to JavaScript, or well, transpile it to JavaScript and run on Node or in the browser. But mainly that's a .NET language. It comes in your Visual Studio if you have one. It comes with your .NET SDK core if you have one. So you probably already have it on your machine. It's open source, and it was open source long before anything else in Microsoft. Since the day one, I think, or at least public announcement, it was open source. And partly because of that, and partly because of less support from Microsoft themselves, there is a strong open source community. A lot of things are done by third-party people, by third-party libraries, and so on. It's very open community, very nice one. And it's functional first. So it's built in a way to push you towards functional programming gently. You can do different things. You can do anything that you can do in the .NET framework. But the defaults are there to push you in the right, on the bright side of things, let's say. So what are the principles? I'll go through them again. You can think of functions, one way to look at them is mapping from one set of values to the other set of values. So you have an input. We love using fancy words for everything, so it's called code, so it's called domain. And then there are outputs, all possible outputs of functions. We call them codomain. And then function maps everywhere, every value on the left to every value on the right. Simple. Now, in OOP, object-oriented programming, usually you build data and functions together. So that's the basic idea of objects, that they contain some data and have some public contracts to work with that data. In functional programming, you are sort of unbound that data from functions, and you pass those data explicitly between functions. So the typical way to reason about functional programs is that you start with some data, you massage them to get other data, and so on and so forth through the pipeline. In the end, you get some more data, and then probably you save them somewhere, do some dirty stuff there. So to help with that, most functional languages have strong type systems. Now, again, that's not true for some languages. JavaScript may be functional, but it doesn't have any types, or, well, it does have a couple, but not many. But most functional programming languages are strong typed. So Haskell, F#, Scala, they're all very strong in type systems. So what kind of types they have? Different kinds of types. Primitive types, as you all know, these are the same types that C# has, so int, string, so on. The first piece of code of F# for today, the first line declares an integer value of 1. You can see that we use let instead of vars because we're not declaring variables, we declare values. And then you can also see that you don't have to declare the type, it's derived from the value itself. More or less the same as in C# with vars. And in comments, I'll show you what compiler will tell you about your expression above. So that comment says that compiler thinks that's a value of type int. That's not something that you write. And the second line is a string, again, the same thing. You don't declare the type explicitly, you can, but you don't have to. And then you get a value of type string back from the compiler. A lot of functional programming is working with collections. So there are a lot of collection types in F#. Actually, these types are the same as C# ones. Oh, no, they're not the same, okay. So the first one is array. You know it from C#, nothing new. The second one is list, but list is actually different in F#, because by default it's not a resizable array list of C#, but a linked list type. So every element points into the other element and so on and so forth, the one you probably learned at school. So because a lot of F# code is manipulating on a single element of that list, linked list is more optimal to be used by default. You can also use the other one. It's called resize array instead of list. And the last one, it's called sequence in F#. It's basically enumerable from .NET. You can see that you can write most types in two ways, like string list is more F# way, and more generic, more common way is list with square brackets string. Same idea, same type. Now, algebraic data type, as you learned, they are built into the language, and that's like again #1 feature of the language, that they are always, and they are very easy to use, and all the language is built around the algebraic data types. So two types, one is product type, and the other one is sum type, or coproduct. If you want to write a tuple in F#, you write it with a star. So int times int is two values of int in one type. If you want to write an OR type, you write it with a bar. So the bottom two are, the third one is integer or string, so it can be 1 or it can be hello F#. And the fourth line is byte or bool, so it can contain like 256 values of byte or 2 values of bool. So in total 258. That's why it's called sum type, right? You sum the spaces of values. And it's literally as simple to declare those types. Now, how do you use them? So product types are more familiar. Let's start with them. First, you can declare it as a tuple. So the syntax with on the first line, that's a tuple. You know it from C#. It's two values. Because they are with decimal points, the compiler decides that's a float times float. That's your type. Also, you can give the type an alias. So in my case, I gave the type float times float, sort of human readable name geopoint, because I'm going to reason with latitudes, longitudes, or x, y, and so on. So it's just an alias for the same type. Geopoint is float times float. From that point on, I can use geopoint just as a readable name of two floats. Then a nice small F# feature, units of measure. You can declare it with special attribute a type, in this case m, and that's a unit of measure. And then you can use this unit of measure with basically any, in this case, for example, with integers. And then you know that you're here declaring meters and not just number. So when you get a distance, you know that's meters, not just a number, which could be centimeter, millimeter, kilometer, mile, foot, whatever. And then if you try to assign, say, meter to kilometer, you will get a compile error, and you will have to take care of converting those values one to the other. So that helps you being explicit and being safe at the compile time. Now the circle type is another product type. It's called record type. It's sort of like a class with get setters in C#, but it's immutable. I'm going to come back to this. And also, it's very easy to declare, like literally 3 lines of code, right? But the idea is the same. You have two fields. They are independent. You declare always the values of both when you declare a circle. And circle sort of represents a point and the radius around it. Now, to declare a value of this type, it has a very similar shape. You say let circle and then equals, and you set every field of that record. Okay? Now sum types, so or types, either or. I declare them with the bars, and I say type zone can be either an area of type circle, so I'm trying to represent something on the surface. It can be a circle, or it can be a polygon, and a polygon is just a list of points. Well, presumably more than 2 points, like 3 or more. I don't restrict it here, so it can be invalid in this sense. And then when I declare values of this type, I have to say what's my case? Like, is it area or polygon? The top one is area, and then I pass a circle that we declared on the last slide. And then in the second case, I say that's a polygon, and then I pass a list of points. And both have the same type, as you can see in the comment. Both are derived to the same type by compiler. And I cannot declare any third value to the same type. Like, there is no way, without changing the type, to assign anything else there. Like, it wouldn't fit. There is no way to inherit or extend. You always have a closed type here. Next kind of type is function. So functions are everywhere, functional programming, so functions all have types. Functions, you can detect a function by that arrow thing. So arrow means function. And if it's just one arrow, then the left one is input value, the right one is output value. So it converts integers to integers, or array of integers to string. If you have multiple arrays, you can think of this as multiple input parameters. So it has 2 input parameters and 1 return value. So then the third line accepts, say, A and B, and returns C, all integers. So the last line is the same. It's a function that has 2 parameters, but the first parameter is in turn a function, which accepts 2 parameters and returns an integer. Okay? So you can go as deep as you want. That's probably something like, who can guess what that function does? What F# people should be. Yeah, it aggregates values of array by applying operation to every 2 elements, and then, so it's like aggregate in LinQ. So you can see already, just by looking at the type of a function, you can already guess what it does. Like, there are not that many ways to implement it that would make sense, at least. So our first function, it's called center, so it calculates the center of our, what was the name of the type? Zone, of our zone. So the function is declared, again, very lightweight. It has a name, center in this case, and then the parameters are separated by spaces. So zone is a parameter. If we had more parameters, it would be zone, space, something else. And then equals, and then the rest is function body. We don't have to say return, but because function always returns, it doesn't really do anything else. And in this case, we match on zone. We check what kind of shape it is. So that's a better pattern matching compared to C#, built-in pattern matching. It asks, what's the shape of my zone? And if it's an area, we'll get the first case. If it's a polygon, we'll get the second case. And then depending on the shape, the actual data of that shape is going to be assigned to the new value, area, or poly, and then we can use that value inside the body of the match. So that's very sort of lean way to deconstruct our sum types. Okay. Also, if I miss a case here, if my zone happens to have 3 possibilities, I will get a warning from compiler saying, I forgot to handle my case. And then usually it's a good practice to turn this warning into error, and then I'm kind of forced to solve this before I can proceed, so that all my cases are covered. F# has generics. Due to some tradition, they are usually denoted as tick A, tick B instead of T or U, but both are used sometimes. But that's the same idea as C#, so generic A type, which can be something or something restricted. And the good thing about F# is that often you don't write types explicitly, and then compiler tries to actually automatically generalize a function. So if you mean to accept integers, but it happens that your implementation can work with anything, like you just append it to a list, then it would generalize automatically, say that your function is actually generic, not integers. So it tries at least by default. So before C#8, there was no way in C# to declare if something is nullable or not. Basically, everything was nullable. And that's a problem. You probably heard like a million or $1 billion mistake or something like that. That a guy who invented null admitted that that was a huge mistake of him. Basically, F# says that everything has to be explicit, so we don't want things that we don't know the shape of, and we want to be explicit whether it's nullable or not. So nulls do exist in F# because that's a .NET framework, but a good practice and standard libraries and so on push you towards not using them in your code, like ever. You should be explicit about your types, and if you don't expect to return type, or well, you don't, if you never return null there, just say your type is not nullable, like geopoint in this case, in the first case. Or if you expect to return a non-value, then there is a built-in type called option, which you're already familiar with. It either has value or it doesn't. It's like nullable, but it's very explicit, and it's nicer to work with, as I'm going to show. And here, just by looking at the type of the function, you can say, I might not get the zone, and I will get a compiler error if I try to ignore this and just dot into it.
Can you just explain in more detail the second statement? So is it correct that it receives a list of zones?
Yes.
And either returns a geopoint?
No. So all except the last thing in those error notation are input parameters. So this is input parameter zone list, this is input parameter geopoint, and this is output.
Okay.
So it gets a list of zones and a geopoint, and then it tries to find the nearest zone to that point. And it can return an option because if you give it an empty list, like there is no nearest zone there. So it would return nothing in this case. Or if it's like 4-dimensional something, I don't know. So type signature is your documentation. You don't look at the implementation of the function, you look at the type signature, and you make decisions about how to work with that function. Yeah. The broader idea here is that you want to make invalid states, like in the sense of your domain, invalid states unrepresentable in your code, so that you couldn't ever come up with a value which doesn't match the shape of your target domain. Let's have an example. You have a contact in the system, and then before you register that person in your system, you have to get either their email or postal address. I don't know, like stupid example, but anyway. And then in C# you write this, like you have name, email, and postal code, but nothing restricts you from either passing all of them, either one of them, or none of them. Of course, you can create smart constructors and validation and help, but just by looking at the type, you cannot tell that either of them is required. So in F#, it's a common sense to be explicit and maybe verbose sometimes, but to declare your domain so that invalid state could not be represented at all. In this case, I create a contact info, which is like either only email or only post address or both. And then there is no case there for no data. And the contact itself is a name plus the contact info. So whatever you do with compiler, your program will not compile if you try to create a contact without any data. And by that, you sort of fight more with the compiler when you write the program, but you get more security out of it. Okay? You can model it in different ways, but that's the most explicit one. The idea is that types are your guard. When you write your program, you maybe struggle a little bit, you think more how to model things, you communicate more clearly in the end to your colleagues, and then once you have this in place, you can trust your type system to sort of guard you through the valid scenarios and do not allow invalid. Of course, to some extent, this cannot be always perfect, but that's inspiration, sort of. That's very handy in domain-driven design kind of projects. So who knows this book? A lot of people. Who actually read this book? Who finished this book? One person, okay. But everybody knows them. There are other books about domain-driven design. Yeah, that's a very difficult book to read. I think I mostly finished it, but it's very hard. So there are different books that are focusing on domain-driven design with functional programming because they argue that that's a good match for the design. So this one is about Scala, I believe. I did not read it, so I don't know quite well. But I really recommend you to read this book, Domain Modeling Made Functional. It uses F#, but it doesn't assume you know in F# or domain-driven design. And it's relatively thin. I think it's like 300 pages or so. You can read it in a weekend. But it's very lightweight and introduces you to both domain modeling and F# at the same time. So I think if you bring something from this presentation, just go get this book, read it. Even if you don't know any F#, you will be able to follow along. It's very well done. Much easier than the blue book. So the purity, our functions should be pure. What does that mean? Well, first they have to be deterministic. That means that every time you give the same input, you get the same output. That's not always the case. In this example, we give a time and then we say, is it more than an hour ago? And if we call it now, we maybe get a true. If we call it tomorrow, it's going to be false, right? So we want to avoid this. I guess a lot of people got like failing unit tests because of dates were out of something, or it was the year 2020 with February 29, or daylight saving time and so on. So that's usually because of things like that. A better way is to just accept two parameters that you want to compare, and then that's going to be deterministic all the time. Again, you sort of do more work, but you keep your code cleaner and more predictable. And of course, things like random numbers and so on and so forth, you want to avoid this as much as possible. No side effects is the next one. So if you want to go for text of words and count the number of words and the characters, you could write a class like that, which has a count method. Maybe you have an interface like iCounter with count method, and then you pass words, and you aggregate the counts and so on and so forth, and then you print them to text, the result. Basic example. But just by looking at types here, count returns void and print returns void, which means that all your functions do is side effects. Side effect is everything except returning the value. We want to avoid this as much as possible. So a better way is to get all the data as input parameters and then just return the value back. In this case, we get like a text or an array of words, and then we return word count and char count. We can model this with types, make it a bit more readable. But the idea is that you get data, you return data. That's all you do. Immutability, yeah, you already learned about this. The idea is that you want to trust that your data are not changed by some other code that you call. If you just declare an object of some type, and that's important to you, and then you pass it to a do-work method, you don't really know if it's going to change there or not. Can you call it safely multiple times? You have to go there, read the work, validate it, maybe read more, and so on, or trust sort of conventions and not like compiler. People make faults, so you better trust compiler. So by default, everything in F#, all the types in F# are immutable. Just by doing nothing, you get immutable types. Everything that I showed before, I think except arrays, are immutable. The top one is immutable. The list with the list is immutable. That's a linked list, so it's immutable. Some types are immutable. Records at the bottom are immutable. So you cannot really say circle.point and then assign something. You would have to create a new instance, a copy of circle, and that's going to be a new one. That's a small difference if you just inside one function, but if you start passing it around, then you know for sure that your circle that you just created yourself is not going to change somewhere else, and you're going to use it much more safely. Same with lists or like options and so on. Totality, again, important attribute of pureness. One more function, square root plus one, random one, mathematical gain. So we think of it as a mapping from input values to output values. everything is fine here, but then there is something wrong with this function. And that is, what if the input is -1 or -4, and then what's the answer in our mapping model of the world? Well, there are multiple ways to solve this, but the good thing is that compiler should make you solve this somehow, and then you should make an explicit decision how to solve this. You can start changing the left part, the domain. You can say that I only accept, well, that's a wrong way to do it to begin with. Like to throw an exception, because this doesn't show in the type of the function. You cannot see that it throws exception. Well, at least you don't expect it to throw exception if you are not thinking about the implementation. So we don't want this. We can start changing the types. We can say that the left part is actually not an integer, but a natural number, so 0+. And then problem solved. We still need to adjust our types, but okay, that's one way to solve it. We can change the right part. We can say we accept integers, but then maybe maybe we do like geometry or something, and then complex numbers are fine, and we start getting like irrational numbers back. Maybe that's fine. Or we can use results. So we don't want to use exceptions for control flow. We want to show in the type that we can return something other than integer. And that's where the type result comes in. So result type, you already know this. It's a sum type of two things. It's either a success of something generic, or it's an error of a string. And I think I made this slide before. This type existed in F# native library, but now it all actually exists in F# library and looks a little bit different. But let's say it's my custom type. So I can return success of A or some errors of strings. Of course, string is not generic enough, so the base library has it generic. And in this case, we can say that our function would return the result, and then square root would look like, if it's less than 0, I don't know how to do this, return an error. If it's more than 0, then it's a success, and then the calculation.
Results and the result, success and error are part of the sharp language?
Now yes, but this one not.
Oh, okay.
So you can also mix and match if you want. Like basically it's an either type. It's known as either, and it's just a sum type. There's nothing magical about the result. It's just commonly used sum type.
So if I try to do an error of 1, won't compile.
No. But probably you want a generic result type, like a result of A and B, where your success can be A and your error can be, and then you can make instances of that type which would be more specific, like integer and string. Again, pattern matching helps as with any other sum types. When you call that function, you get the result back. First, now you know that it could fail. And then if you try to ignore it and just working with success and not working with error, you'll get an error, incomplete pattern matching, and blah, blah, blah. And you will have to handle error case as well. This also works so I don't show it here, but pattern matching is much more powerful, so you can also match on the shape of the value there. Let's say, this is just an integer, but you can say success 1 and then make a case, success more than 100, make a case, success negative, how did I get that from square root case, and then errors match on the shape of errors, like if I got a string back, then this, if I got a, I don't know, exception back, then do that. So matching is quite powerful, and it's quite more powerful than switch in C# still. They try to get there, but they are still very far. And it always checks on exhaustiveness, so it's quite smart enough to figure out whether you figured all the options. I think there are border cases where you can trick it, but hey. Completely different topics, testability. So everybody loves unit testing these days, and the best thing to unit test is a pure function. You give it an input, you get an output, you test your output, you assert something, done. You tested it. So the more pure functions you have, the easier testing gets. Example. So you have a function in F#. You can also mock things quite easily. So dependency could be just another function. Our function under test, system under test, function under test, gets a function and a parameter, then calls a dependency, gets a result back and returns something. It's quite easy to mock it. You just pass a parameter, right? Dependency is just a parameter. When you test it, you pass a function there, which, say, returns a constant always, or throws an exception, or, well, don't throw exception. Return an error. And then SAT is still pretty easy to unit test.
I think maybe it's good to say that sub is the name of the function and the other two are arguments just for like C# people, because maybe.
Yes, yes. So SAT is the name of the function and everything else is parameters. Thank you.
Sorry.
No, that's good. I can imagine that's a bit tricky to read for the first time. But it's so obvious to me, so I forgot. So when you do unit testing, let's say I don't know why, but we test addition. We can say let A be 5, 5 and 10, then add and check that it's 15. So very easy to test pure functions. We can say that that's not enough of testing for addition, so we can start doing parameterized testing. You can just list several cases for parameters. You can do the same in C#. And then every value gets assigned to the proper parameter on the same position, and then the same test runs 3 times. But you can also say that, hey, I still need to come up with all the test cases. Did I cover all the border cases, and so on and so forth? So the next step in this hierarchy, which is quite popular in F#, but not really specific to F#, is property-based testing. So you can say, I have my function add that I want to test. I want to come up with some generic statements about that function, which would hold with any possible parameter. For example, if you add 0 to something, you will always get something back, so that same something back. That's a property. It doesn't matter what value, it's always true. Or if I add a plus b or b plus a, that's always the same thing. That's a property. In this case, we can write tests like property and then put special attribute there is a framework which does that. And then the framework will take care of generating all kind of possible inputs, all the garbage that it can think of, all the corner cases that it can think of, and try to break your function. And if it finds a possible break, it will fail for you. Yes?
Which framework?
What's the,
Which framework? Which testing framework?
what's the name of the framework?
FSCheck?
FSCheck, yes. Thank you.
That's
Perfect.
built-in, right?
Huh?
It is built-in, or not?
No, it's not. It's a standard like third-party thing. There are multiple, something like Hedgehog or this is FSCheck. You can actually use this with C#. But because F# types are more fit to this, so it's easier to generate sum and product types in F# than to generate classes in C#. So in C# you would have to come up, if it's not integer, of course, to come up with like ways to generate your types more explicitly. In in F#, if you just use records and sum types, it's pretty easy to like create instances of all possible combinations of those and just pass them to functions. Of course, it doesn't check like all possible values of integers. It comes up with 100 by default, or you can tune this, but as diverse as possible. It takes some learning. Honestly, that's quite difficult to apply to your code. It's easy with addition, but it's quite difficult to apply it in your domain. But once you like struggle for a week, put yourself in the right mind, you'll start finding interesting properties. And we use this to test workflows with some dynamic parameters and branching and so on, calculating about how like production machines work. And it would find bugs that you would never think of easily. Well, not always, but I had several instances when I would spend, after the test failed, I would spend like 15 minutes figuring out how is this possible, and then I say, okay, that's how it got there. Yes?
Every time it runs, it gets different values?
you can tune this. You can say, by default, I think it's deterministic, so gets some seed and then it puts them the same values, so that your tests are predictable.
Yeah,
But you can switch it off. I don't remember which one is default.
By default, seed is randomized.
Okay.
But you can set it.
Then it's the other way around.
It
Yes.
also output the seed. Once you get a failure, you want to test it with the same
Right.
seed. So then you can configure it with
Yeah.
the seed and you will have.
Yes, exactly. Every time it fails, it will print seed for you, so that you could put this seed into your test and then reproduce, like debug. And then if you're debugging and you're stopped,
it runs successfully a couple of times or many times, and suddenly
yes.
there is
Yeah, that's a potential problem. Honestly, I saw this in production. Like it works for 5 days and then it failed in 6 because it found something. But that's
Combine it with the fixed case as well. So
yeah.
it should be an addition.
But that's probably a good thing. Like it's better to fail on 6th day and find a bug rather than succeed forever still having the bug. So it's a separate thing. Like there are presentations on just property-based testing. You can also use it in C# if you want to try. Okay, how do we compose applications out of simple functions? In OOP world, we have all those great books with design patterns and enterprise architecture, so on. We all studied those. We know this guy. We know that code should be solid. Who knows what solid is? Like actually, I think it's like single responsibility, open closed, Liskov, something about interface and dependencies. Yeah, but basically our code start looking like this. It's a small class. Probably it gets some dependencies through constructor. It has just one function or method because of single responsibility. It has probably implements some interface and has some data inside of it. So a lot of code starts looking like this. Who thinks that's the case in their code? Not many people. Okay. I definitely do this. Like I think that's one of my code classes obfuscated. And then you have things like this where you need to combine. That's definitely a class of mine obfuscated. And then that's a real diagram of dependencies of that service method. Also real, sorry. I thought it was a good idea when I did this. But, yes. So in the OP world, we have these nice patterns. What are they in functional programming world? That's, again, a screenshot from that same guy who wrote a good book that you should buy. His name is Scott Flashin. He's just a great F# advocate, let's say. Of course, that's not to say that functional programming doesn't have any patterns or idiomatic ways to solve common problems. It's more of a joke, but it's to say that they are quite different from what you already probably know from OOP. And a lot has to do with combining functions in different ways together. So coming back, we have our nice pure functions. They get A as input, B as output, or anything else. They're pure, they're total, everything is strongly typed and immutable. So how do we make programs out of that? We probably have more than one function. So simple case, we have F function and G function, and F gets A, returns B, and G gets B and returns C. How do we combine them? Well, that's easy. We just put those arrays together and make a new function, H, which gets A and returns C, right? So in F#, this is an ugly way to write this, but very explicit way. So we have a function H, which accepts A. Now you are learning how to read F#. Then in the body, you can declare a value B, which is the result of calling F with parameter A. And then you pass B to function G to get C, and then return C. Yes? Okay. But that's sort of a very explicit way to write this. An easier way is this. So H is F G. So that composes two functions together if their types match. If they don't, then you will get compiler error. But because it's such a fundamental operation, there is an operator for this, which does this in one-liner. So this is exactly the same as this one. It declares a new function, which would get an input parameter type A, which you don't see here, because it just combines functions. It gets it from F. And everything is derived by compiler from types of F and G. You don't have to type any types or anything. It's very compact. It's not always very easy to read, especially when you're new. So it's still debatable how much of these things you want to use in your code, but that's a possibility. The cool thing about F# is that this is the definition of that operator, literally from the base library. It's just a function which gets 3 parameters. Now you should be able to read this already. So it's a function, well, because it's an operator, it has also the braces around it. It gets 3 parameters. F and G are functions, and X is just X, something. And then it calls F with X, and then calls G with the result, and returns back. You could make this operator yourself if you want different shape and you hate your colleagues, you can create your own operator. At the bottom you can see the type, so it's a longer, but you can read it now. The first parameter is A to B, a function. Second parameter is B to C, a function. Third parameter is A, anything really. Could be a function. Could be that operator, I guess. And then C is the result. So where is this useful? Let's say you have a service, some sort of more business typical thing. It gets a JSON. Oh, sorry, questions?
Yeah. Sorry about the previous.
Yes.
Let me. I'm assuming that I can also. Oh.
Can I try the microphone to you?
Sorry. Hey. Thanks. So I'm assuming that I can also. What?
Closer.
No, hey.
It's
Hey. Oh. Okay.
One.
So I'm assuming that I can also combine a whole bunch of these. Combine several, more than 2 functions?
Like you can here, yes.
Yeah, just chain it or something?
Yes, I'll have an example of that in 2 slides.
Oh, yeah, I thought I'd wait for the next slide, but it wasn't the next slide yet, so. Okay,
One more question.
On the next slide, please. Yeah, the last A, the arrow C, shouldn't there be braces around it?
No.
No?
So the braces are functions as input parameters. We have 2 functions and a value. So the last 2 are not one thing, they are 2 things. An input parameter and an output result. So
oh, yes.
that X is A here, and the result is C.
Okay.
These errors, yeah, are hard to read. Why do you separate parameters with these errors? Not commas or something else.
I mean, they are hard to read until they are not. Like, they are not hard to read too much to me. Yeah, I'm not even touching Karin yet. Well, I will. Sorry. Okay, so if you have things like that and you implemented 5 pure functions in your code that sort of convert JSON to DTO, DTO to zone, then do something with calculation in the domain, produce a point, and then sort of need to send it back over the Y as a JSON. So if you have 5 functions like that, you can combine them just by doing this, if all the types match. Again, if types don't match, like exactly match, it will fail compiling. And it's a good test, sort of, if you're got all the types right and if your pipeline is good. It's notoriously difficult to debug code like this, because there is no breakpoint here, kind of thing. But yeah, it's good to use this code, in my opinion, on like that higher level where you compose services, where you compose multiple functions together, and there is no logic at all anymore, and you just go for the types. Yeah, sure. There is no there is no step over really here, because it's like combined function. There is nothing in your code, really. So what if we are less lucky and B is not equal to C, so we cannot combine them immediately. Well, we need some familiarity between B and C to be able to do something useful. So there are typical use cases. A very typical use case is that your first function produces a collection, and then you have a function which just gets one element there. So again, those points, elements, and so on. You produce the points, and then you have, for every point in the list, you want to do something, for example. And your target function obviously wants to get A, and then return a list of C. So apply function G to every element which got from F. In this case, usually you could use some other function that would shape your existing function in the right way so that it could match. So in this case, you use a special function list.map that gets a function as a parameter, and then it converts, sort of converts your function to accepting a list of B and returning a list of C instead. Again, that's like selecting your link queue. You're doing the same thing in link queue, but it's called list map in F#. And list map, more general functions like that are called higher order functions, and that's a fancy way of saying that they accept functions as parameters. So all higher order functions just get other functions as parameters in order to do something useful. And the module contains a lot of them, like map is like select in C#, filter is like where, fault is aggregate. And just by reading types here, you should be able, again, to sort of guess what this function does. So for filter, it gets a function which, for an element of A, returns a bool. And if A can be anything, how can we implement this function otherwise than filtering the input list to output list? Notice that A is here and is here, so we cannot produce data here. So I guess filter is like the only implementation, maybe not filter is the other one.
So in the filter, shouldn't the return be a list of bool?
No, you want to filter, so you have 10 integers, and you want to filter the ones that are higher than 10.
It's like in QR. Okay.
So you get a list and you return a smaller list or the same list.
Yeah. And it's the predicate, the first
Yeah,
function.
predicate, yeah, exactly.
In default, the third parameter shouldn't it be list of A?
It is. This one?
But it's written differently.
Oh, yes. I mean,
The order.
yes, I think my formatting is correct. Actually, this one is correct, and these are not.
Okay.
Something is broken. So again, there are two forms to write this. This is like with a space list, and then you can do square brackets, but you cannot do this. I don't know why I have it. This will not compile, but that's a standard library, so it's fine. So it's very typical to use those functions to build other functions and combine in your custom ones. In this case, it's like link queue statement you can imagine. You get some input, you produce a list of A's, that's why I have S there to sort of identify that it's a list. And then you start maybe mapping, filtering, folding. That sounds a bit abstract in like this example, but you can think of a lot of examples where you manipulate collection as like the main thing that you do as you go. So that's one way to write this. Again, values on the left side, calls on the right side, but that's again a bit verbose. So another way to write this is another operator, which is forward pipe operator, very commonly used in F#. You should read it as, my function combo gets an input. Now I take this input and I send it to this function as a parameter. Whatever I get back, I will send it to the next line to the as a parameter. Whatever I get back, I will send it to the next line, to the next line. So it's piping forward. I think the next JavaScript is going to have this. It's a very common way to write F# code. And again, all the types have to match. So if you make a mistake somewhere, you forgot map just past G, it will complain like I cannot fit my list into your function that accepts P. So it's still type safe and so on. But again, this code and this code, they are the same thing. You just don't have to declare every time. And it's nice because you read it from top to the bottom. So when you read a function, you go, okay, I go like this, instead of going like to the right, back, to the right, back, and so on. It just speeds up reading. And again, the cool thing about F# is that this operator is just a function that you can define yourself again. And another exercise in reading. So this is a function called pipe, which has two parameters, x and f. And just from the names, you know that f is the second parameter, but it kind of makes sense if you think of this. So f is a function, and then x is passed to this function in the body. So it just kind of swaps two parameters. And that's enough to pass values through. Who actually thinks they understand this? Okay, that's good. So some people love creating their own operators in F#. I'm generally averse, like they are not that readable. A lot of people do like fish operators and fish and blah blah blah. I saw some code with just operators on all lines, and then you have to know what they mean. I guess once you know them, it can be fine, but yeah, that's probably a bit too much. Everybody knows this one and the other one in F#, so it's fine to use them. Maybe most of the time you should stop there and just don't use any other operators, any custom operators. We already kind of alluded to this, but in F#, compared to C#, you can have functions that accept multiple parameters, and then you can only pass some of them, but not all of them. So in our case, list map has two parameters, as you know. A to B as a function, and then it accepts the list to map. We can say, okay, I just pass the first parameter, and then the result of this passing the first parameter is another function. So when you do this, you produce a new function which accepts lists and returns lists. Nothing really happens here. You just redeclare a shorter name for a bigger function with specific parameter. And you can do it as much as you want. So if you have like 10 parameters, that's not healthy, but maybe. You can pass 5 of them, and then on the next stage 2 more, and then 2 more, and then finally call it, and then all of this will evaluate. Where is it useful? Well, it was useful here, because that's what we did here. These lines are passing one parameter, and then the second parameter would come later. And that's also very common, especially when you have your function which accepts two dependencies. This is like constructor injection, sort of, in OP world, where in your program you would inject your dependencies into functions. And then those functions would operate on a smaller set of parameters that they care about. So that's another example, the graphics for the same thing. If our G function accepts two things, B, but also some nasty C, which prevents us from matching them, what we do is actually pass C earlier, make a new function which only accepts B. And then we can match together. So, and at the bottom, it's like, again, pipe operator example, where you have a function with two parameters, and then you pipe the one through the others. And GC is a partial application of the function. You can also write this like this, but at this point, this sort of gets fishy. Like, you can do this. It's very concise and brief, but it's usually the advice is to be a bit more explicit and stay here. You see from top to the bottom. Here you sort of start to apply it. Like you don't really know where to start to think of this. Option type. I already mentioned it. It's a container type, and it's also another common thing that you pass around functions with partial applications and pipelines. So option is just an either type with two possible values, some of something and none of nothing. None doesn't contain any data. You can say number is sum2 or no number is none. That's the same type. They can be passed to the same function. And then let's say you have a parse function which gets JSON but may fail to parse JSON. Yes? Question?
This slide, suppose you have two of those. You have option B, that's also sum of B.
Yes.
With none, combined with none. How can you know, if you say let no number is none, which of the two options does it choose, or do you have to be explicit then?
It doesn't. It doesn't care.
Doesn't care.
Because you can pass no number also to
Yes.
get a function that takes like ints and strings, for instance.
Yes. It's a none, like it's the same thing.
It's like a T, so it's like generic.
It's sort of like a singleton value none that's used everywhere. So if you have function parse which gets a JSON string and then returns a DTO or doesn't, so it can fail, we can represent it as an error as a result type with errors. But if we don't care about errors, somehow we can say it's an option, and then validate DTO to a command is also an option. So how do you combine them? Well, you can write parse and validate that gets an option. It calls parse, and then use match statement that we learned before on the result to match some value and none. So that works, that's fine. But also it's a bit less linear than we would like it to be. So instead you can rewrite it as you get a JSON, you pass it to parse, and the result, you pass it to something called option bind with the second function. And that option bind is a higher order function which helps you achieve exactly what's here. Like it's implemented exactly like this. But it's in case of sum, it would call your function and return the result. In case of none, it just short circuits sort of. If you have 15 of those, it would stop there and don't call any others. So it's another example of higher order functions and making non-linear sort of code, more traditional code in statements sort of, to very linear structure with higher order functions. And bind is the flat map from the previous presentation. Every language seems to have their own names for the same things. An option is a monad, but that's, yeah. Yes. Yeah. I won't get started on that. Another form to do the same is just parse and option bind validated. But again, you sort of lose that linear reasoning. It's kind of linear, but I still prefer this one, where you get the parameters explicitly and then you pass them around, than just pure composition of functions. So, yes. Patterns that we learned are container types, you use them all the time, options, results, lists, whatnot. Your own container types that you create, high order functions working with that types, knowing how to sort of open them, do something with them, and put it again into the container. And then we try to structure our composed functions as sort of linear flows, as linear as possible. That's a good way to do it. So again, what about side effects? If we don't have just pure functions, what do we do? Well, we already learned in the last presentation. We try to push them to the boundaries. So you have multiple pure functions that you compose nicely, and then you sort of try to do your I/O at the boundaries. Same code. Sometimes you cannot do this. You'll be less pure, but F#X is actually not religious about this. You can put I/O anywhere you want if you want to. You shouldn't. You should try to minimize this, but there is no like language feature which will prevent you from doing this, like Haskell, like in Haskell. And those functions, pure and I/O working, they should be different in nature. Your pure functions should be specific to your domain. They should contain all the logic. It should contain very explicit with types, and like very well tested with property testing, ideally. And I/O functions should be dumb. They just do something and pass data to pure functions. So, and then unit testing maybe doesn't make much sense. You do more integration testing and end-to-end testing with those. So in the application, you have a bunch of pure functions, and maybe for some input points, you sort of add a couple of I/O functions. That's your one service in your HTTP web service or something. Maybe the second one sort of overlaps, but does a little bit different thing. And then that's the mental model for the kind of application you want to get as a result of making functions, like F-sharp application. So you have pure core functions, and then on the borders you have non-pure I/O functions. And if you're familiar with things like onion architecture or ports analytics, that's the same thought basically. You have functional business logic domain specific core, and then you structure your I/O as dumping around it. And so the problem with this, so who has used onion architecture or ports and adapters in their application? And who really succeeded with this? Like, it worked great. Sort of, kind of. So what I've heard a lot is that it's very hard. It's a very hard battle. So you have to push really hard uphill to make this consistent. And then you go for vacation for a couple of weeks. You come back and it's like all dismounted and done differently. So the idea of F# is to turn it a little bit. Of course, it's not perfect, but to push you to the right direction so that the defaults of the language sort of make you not do the work, but accidentally end up in that nice sweet spot. Of course, not perfect, but sort of the right intention and vector. One thing which is underappreciated about F# is that, like, don't look at these pictures yet, I'll explain, they are not the same thing. F# does not allow you to make circular dependencies in your code. So F# code is from top to the bottom. It's always like this. You cannot suddenly at the top reference a type at the bottom. Some people are very annoyed when they start, like, why do I have to structure, like, order my types? Well, but I have also the files in Visual Studio you have to order. But that's very useful because you end up avoiding loops. And that's super useful when you have complex project like that. So that's a diagram from some C# project where everything depends on everything. And that's not the same project, like, it's not that they refactored this magic. But that's a shape, just to show the shape of directions. They all go from left to the right in F#, all from bottom to the top in the code. And that helps you manage your complexity. Again, you have to make decisions somewhere. Well, you would make a circle dependency, you would sort of rethink how you model something and come up with more logical dependency order. If you look at C#, they basically what they do is steal functions, features from F# for the last 2 versions. Local functions, tuples, deconstruction, pattern matching, which is still not there, but sort of, and non-nullable reference types. All features that exist for years in F#, like from version 1. So yeah. I think they discuss records next. Yeah. Records have a nice property that they have comparison, like same comparison out of the box. They compare by field and by references. So you don't have to re-implement equals and get hash code.
Now you also can declare your members as read-only, so that sort of like making them by default immutable in C#.
Immutable, but not comparable properly.
Yeah, that's a different.
Yeah. Yes. True. So they are getting there. Maybe they will get there in 10 years. But yeah, of course not everything can be done in F# that can be done in C#. It's a big example. Oh, okay. Well, honestly, you can do null reference except in F#. If you call C# code from F#, you might get null reference. You can dereference null in F# as well. Like, that's .NET framework. It's proper interop, so nulls are there. It's just that they are harder to get by. So to wrap it up, thanks for being patient. Why learn F#? Well, first point is that it's a great tool, actually, to use for yourself. Like a lot of people, they learn some F#, they have some pet projects, they start using F# for their pet projects, they find them to be productive, maybe they use it at work at some point. Like I worked in 3 companies in the last 4 years, I used F# in all of them. One was F# only, the other 2 were a little bit of F sharp. But still, you can find places, especially things like data manipulation and examples like that, yeah. It's very easy, natural to use F sharp in some scenarios. Also, it's a useful tool for sort of broadening your mind. Even if you learn F sharp and you still continue to use C sharp, you're gonna write C sharp differently. Well, you saw the presentation, that's sort of more like to a larger extent, but also in small things, like null checks, being suspicious about exceptions, not total functions, and so on and so forth. Different way to test. You will just change the way you write C sharp code after learning and practicing some F sharp. And finally, it's fun. Some people enjoy just writing F sharp for fun, and a lot of people report being very enthusiastic about different things. That's partially why there is a lot of open source F sharp all around. And with this, thank you for staying so long, and I can take some more questions.
Let's do 3 questions, and then we can have another drink and ask the other questions. So if people, if they want to go home, they can go home. Let me throw the microphone.
It's not going to be a question.
Yeah. No, I mean, they always sort of say that you can do functional programming with every language, right? But then, like, I wanted to pinpoint, like, there is some languages, like Haskell, like ML languages family, that they have this automated type inference, which is like this Henry Miller, I think it's called. I don't remember exactly, but so I don't know if you want like to, because sometimes I find it difficult to explain to other people what is the actual difference, like that you cannot do with C sharp. Like
so I think in all examples that I gave of F sharp, you never saw me declaring types, right? It was always inferred. So that's one way to simplify your code, because your actual types quite often are quite long because they are very explicit, but the compiler does a good job figuring out based on other types what types you're using here or there. So that's one thing. There's some type, I think that Hidden Miller's system is about, there's some types, product types, and they really help you model your code. That's one big thing missing from classic C sharp OP. I think they would also want to do this in C sharp at some point, because it's just that useful. Yeah, so you can do function programming in many languages. I saw LinQ in Go the other day. No, like, it's not very nice. But again, the language gives you the defaults that are applicable for this target scenario. You can abuse other languages to sort of try to fit them into the same paradigm, but it's counter language, and also you will meet people who would question your choices just because it doesn't look like proper language, like that language. So I guess it's not binary, but it's easier.
No, sorry.
Okay, so we in the first talk we saw a push from OOP toward functional by introducing all kinds of concepts and to make the transition easier, so to say. Is there an effort from the F# community to make it look a bit more like C#, OOP, and by that way pulling people in? And why does it suck?
And changing the language.
Have frameworks that look more like OOP. I don't know, maybe some language extensions.
It doesn't make sense. Like I think the general state of the F# community is that if you want to do functional, do F#.
Yeah.
If you don't want to do functional, do C#.
But it's But can't you say that the same for C# and having functional concepts in C#?
So I think the C#, as we see from features, they try to sort of find gold middle ground where they would use some features of be it more expression-based, more explicit, type-safe, without introducing all those
Yeah.
harder things, but also that limits their creativity. Sort of. If you look at how long it takes them to like introduce small fish, of course that's a language which they can break and have a million customers and so on and so forth. But
Yeah.
it's hard to fit.
Yeah, I can understand.
First to a language which was not designed for doing this.
Yeah.
So I think they will never really converge. And from F#, I don't think there is any.
No, I was just wondering if. Yeah.
Like you can do classes, and object programming is actually, I did not show this
Yeah.
in F#, but object-based programming, so not object-oriented with inheritance and so on. But objects are quite useful in F#, but they are different thing than objects in C# to make it complicated.
Yeah. Okay.
They are sort of like single object thing without classes.
Yeah. Yeah, it's hard to.
So interfaces are also useful in F#. Inheritance is probably the biggest no.
Yeah, I can imagine. It doesn't fit with the.
You can
with
do
the
it,
flow.
but even if you try to do this, it would look horrible. Like the language is designed to look horrible if you do it. So you don't do it often.